Sikole ngambulo luku. With whatever we do. Jioni safu no la. With whatever we do. Hale yide munyu skula. Nyepamne ne kudlukula. Nyepangi ragala gena. Nyepamne ne kudlukula. Ibuloke nungoto ni beti sola. Ibuloke dato ni betoto.
Mingi Congo.
Lamin.
Na?
Lamin te jibe norin te nyamen Lamin.
Kabana wulo kono.
Wulo kono nyinta mo Lamin.
Pabilenki.
Muna ngata afamole.
Haina.
Ngata. Ngoto le. Fabrama.
Mingi. Baba nyole.
Ngoto le Fabrama.
Namu jumala kan kuma diteng.
Fabrama.
Jumala mu.
Ndele bare muso.
Lunda mana.
Famo kata.
Jamani mbere.
Alindo ko.
Jamani.
Bari ngoto man kontande.
Bari jamani fana na mundu wa man kontan.
Ngoto minaka ngalamin de fom filitala. Lamin jibe nori nyala.
Lamin ila siram sama ne benki. Yala so tol sayndi no ko mo lakko momo.
Ngoto.
Nam.
Itedinte yalo ne Lamin hakilo diata bake karamngoto. Anu sainteng ministry ko di ngole si suko na amanke ko do holiday la
si bitun
bagona de
ala ni ku kede namo balo
na ko sa ka bulo be ala ni je
ngoto
nam
ngoto mon kontan fere
jamani mu nekata
ite Lamin ki wulo ko no nyinta mon ko do fete malo Lamin nyanta sila la be la moy kala karango
jamani karamol be sorande ne ko fasita wulo ko nako
karamol ma soron ni ko karamol soron da amanke ko holiday lem ngoto dindi ngo nyanta sila la ala karango la moy yamen kamen fue man kontaan anda mande
alla nyin kombo courant danda la kombo len do la jankara mo lo do kamen courant ma do la kombo nje kara mo soron Lamin ada lo nyino la e ko yana di mo Lamin ya mo na fonye
bir kabin mina kan tambita nteri mañing Fatou tambite la sugal ala dinngol bebe siri be la moy ka
Fatou danso am fana tambita jele ni subala la ngaje dinngol be jet talanta nen kili warol e be seri jelet
sa Lamin fadante ku kili wo ke no la ba Lamin bita ka wulo ko no Lamin
amandara fennela
ite dine ko ni man si yakari lesuno la moy radio to balon na
muneka ke afonde ba nyara ni alon
telentel jikot
afonde ba munebe ke
ite balon tel be jikritel ni man karambe ku kele yaje nata karana mbasa malaya ay tarije
par ñarande kombo courant ho findira kombo ide nara yede ni sonka bay ko Lamin mañana tala wulo ko kara mo be so da fanya membe kala
ko to wole nati ba ngal ni Lamin kuntala kombo courant o ka fa me kombo courant asototal wala kinay ko esi suwo kono bari ni ko esi suwo kono ibe karangol dike la radio lin telel to hani tele masoto to nyaay man tele soto la bongo bar radio be bulen koto batiri sanga ay si ay alamo
sa do kala nyaadi
ko ta o bulaji
abe o kala nyaadi
kamun ke nyaadi
radio abe wala moy la ibe mona falaje
ibe la karandirol kala jele
ti talle be radio ko men ga karandi
ila subject ro baby jele baby jele
wala nanga chocho moy fa dan so wolya ngombe tambi kana ngadi ningol je be ikadum bungo ko kala mala mo
asototal de
Lamin mala be karawala de
bari
laftalal ideal on ko inde every year second wala fourth
muna ni ko nde ko folle sini lamba nde le sini lo ne ba
say mba foke en koto wole fango yen wulindi yalo famo keta bat ñu fanam bulata ko ko me yen nati jambi Lamin nyanta karana ntel be jiko be nyineka ya bulay kara wulo kono ta kilar ya bambalo yo be bulaje en koto dindi ngoy si ayala le sino la moy radio
wara ka munda kara mo man soro Lamin nyanta kara si suuna radio
la sila le ayala le sino
dal ko korno ko smolon
kilar ya
mo be ngela ko momo say mi do ni fono kera
mengi bruzo
ndebe ko do la da ba rosa no radio ba no bari woro radio ni abe jele ba ngamra do man nembe buljan dala nyara nyar fo ko fendi mo la Lamin tayra ba rosa
bara te ku folo ajibe nori nya Lamin tamete ku
teku
bari ko do famo ke
imagine nani nyambol sizol le keje kisigi man sizol ndol le kafun ka nyoma bari nyambu kino ni manya na kafindi ni nambe ko rozor la ga
limbeta de be nyambo do dilanna
nyara ni ko rim fennat nyara nata
koto bari famo ke da
ngata bungono tammi bungono nyara ngando ko fele ko ke baru nganda ni pelo la ndija
iyo awe better la
bungono bismillah bisudi yara
ye fongo tanka sina dolu tanka koro ta koro
Good day, viewers and listeners. Welcome to yet another lesson on the fractions. And of course, this lesson is targeting students from the grade 4 to 6. And in this lesson, we are going to discuss addition and subtraction of fractions with unlike denominators. That is where we are going to center our discussion in this lesson. If you can recall, in the previous lesson, you've dealt with addition of fractions with unlike denominators, but in this lesson we are putting it together with subtraction. So it's going to be addition and subtraction of fractions with unlike denominators. So without wasting any time, we move to the lesson proper. Okay, that brings us to the corrections. During the previous lesson, you were giving some try questions, some questions to try. Now we are going to do the correction of the try questions. The first one we have 3 all over 8 plus 1 all over 5, and the second one is 3 all over 6 plus 4 all over 7 plus 2 all over 4. So we are going to start with the first one, that is 3 all over 8 plus 1 all over 5. In adding fractions with unlike denominators, if you follow the previous lesson, you were told that we will have to find an equivalent fraction to each and every one of these fractions that will have the same denominator, and then we work it through. As when we are dealing with fractions with the same denominator, you can see that we only do the operation for the numerators and we maintain one denominator. So this time also, hence we are giving unlike denominators, we will make sure that the denominators are the same before we move ahead to solving the problem. So the procedure is the same, just like in the previous lesson. If you want to make sure that these two fractions, that is 3 all over 8 and 1 all over 5, they have the same denominator, although you can see that the first one has a denominator of 8 and the second one has a denominator of 5. So to make sure that these two denominators are the same, we are going to take the first fraction and multiply it by the denominator of the second fraction. That is to say, we are going to take the fraction 3 all over 8 and multiply the numerator 3 by 5 and also the denominator 8 by 5. That is for the first fraction. Then we move on to the second fraction. We have 1 all over 5. So we are going to do the same thing. We are going to multiply the fraction 1 all over 5 by the denominator of the first fraction, that is 8. So we are going to have 1 times 8 all over 5 times 8. That is simply what we are going to do. And to do that, we have 3 all over 8. We are going to multiply the numerator, that is 3, by the denominator of the second one, which is 5, and the denominator as well, that is the denominator of the first fraction, 8. We are going to multiply it by the denominator of the second fraction, which is 5. Then we add. Move on to the second fraction now. The second fraction, we have 1 all over 5. 1 over 5, we are going to multiply the fraction 1 over 5 by the denominator of the first fraction, which is 8. So we are going to have 1 multiplied by 8 and 5 also multiplied by 8. So if you do that, you will see that we are going to multiply 3 and 5 and also 8 by 5. We are going to multiply 3 by 5 and also 8 by 5. 3 multiplied by 5 all over 8 multiplied by 5. So 3 times 5 will give us 15 all over 8 times 5 will give us 40. So that does it for the first fraction. Then we move ahead to the second fraction. What we have is 1 all over 5. So we are going to multiply 1 by 8 and 5 by 8. So 1 times 8 is simply going to give us 8 all over 5 times 8 is going to give us 40. So you can see that we have attained our objective in making sure that the denominators are the same. So in both fractions, we have the denominator as 40. The first fraction is 15 all over 40 and the second fraction is 8 all over 40. So simply we are going to add following the rule that if you have fractions, if we are adding fractions that have the same denominator, you are going to add the numerators and maintain one denominator. So we are going to have 15 plus 8 all over 40. So this is going to give us, what is 15 plus 8? 15 plus 8 is 23 all that over 40. So because we want to leave our answer in its simplest form, if you look at this fraction, whether we can have a number that can go into 23 and 40 without any remainder. Technically, there is no number that can go into 23 and 40 without any remainder. So our final answer is going to be 23 all over 40. That does it for the first one. Then the second question, we have 3 all over 6 plus 4 all over 7 plus 2 all over 4. So here we have 3 fractions that are adding. But if you observe, the denominators are different. So in order to add these fractions, we will have to change each and every one of those fractions to their equivalent fraction in such a way that they are all going to have the same denominator. In order to do that, we said we are going to take the first fraction and multiply both the numerator and the denominator of the first fraction by the denominators of the second and third fractions. So the same thing will appear for the second fraction and the third fraction respectively. So to start with the first one, what we have is 3 all over 6, and the denominator of the second fraction is 7. The denominator of the third fraction is 4. So we are going to multiply the numerator 3 by 7, and also we are going to multiply it by 4. So this is going to give us 3 times 7 times 4, and the 6 also we are going to multiply it by 7 and also by 4. Then we move ahead to the next fraction. The other fraction we have is 4 all over 7. Remember, we are trying to add 3 all over 7, 3 all over 6 plus 4 all over 7 plus 2 all over 4. So we are done with 3 all over 6. We are moving to 4 all over 7. 4 all over 7 here, we are going to multiply this fraction by the denominator of the first fraction and the last fraction. The first fraction is 3 all over 6, so we are going to multiply it by 6. And the last fraction is 2 all over 4, so we are going to multiply it by 4. So we are going to multiply 4 times 6 times 4, and 7 also will be multiplied by 6 times 4. So that is it for the second fraction. Then we move to the third fraction, which is 2 all over 4. 2 all over 4 here is the last fraction, and we are going to multiply the numerator and the denominator of 2 all over 4 by the denominator of the first fraction and the denominator of the second fraction, which are 6 and 7 respectively. So we are going to have 2 times 6 times 7, and 4 also we are going to multiply it by 6 and also by 7. Okay, we have multiplied all the fractions with the denominators that we should multiply them to. So we are going to do the simplifications. So the first one, we have 3 times 7 times 4 is going to give us 3 times 7 is 21, and 21 times 4 is going to give us 84. So we have 84 all over 6 times 7 times 4 is going to give us 168. That does it for the first fraction. Then we move to the second fraction. What we have there is 4 times 6 times 4, and 4 times 6 times 4 will give us 96 all over 7 times 6 times 4 will give us 168. Plus the last one, which is 2 times 6 times 7. 2 times 6 times 7, which is going to give us 84 all over 4 times 6 times 7, which is 168. I think we need more space to do that. So now we have, if you observe, we have the denominators are all the same now. So we can apply the previous rule that says when you have the same denominators, you only add the numerators. So in this case, it is going to give us 84 plus 96 plus 84, all that divided by, you can see denominators are all the same, so we're going to have only one denominator, which is 168. Then finally, if we add 84 plus 96 plus 84, the answer is going to give us 264 all over 168. So what we have is 264 divided by 168. Looking at this fraction, it seems we can break it down. We have a number that can go into both the numerator and the denominator without any remainder. So 2 can do that. So we can take 2. 2 goes into itself is once, into 6 is 3 times, into 4 is 2 times. So if we divide 264 by 2, the answer is going to give us 132. All that over, we take the same number to go into the denominator. So we realize that 2 cannot go into 1, but 2 can go into 16. So 2 into 16 is 8 times, and 2 into 8 is 4 times. Now we have reduced the fraction by 2, only to realize that we have 132 divided by 84. Again, if you look at this fraction also, we can still break it down using 2. So we go ahead and do that. 2 cannot go into 1, but 2 can go into 13. So 2 goes into 13 is 6 times, remainder 1. So 1 and 2 will give us 12, and 2 goes into 12 is 6 times. So if we divide 132 by 2, the answer will give us 66 all over. Then we go to the denominator. Again, we are going to use 2 to simplify that fraction, that number rather. 2 into 8 is 4 times, and 2 into 4 is 2 times. So if we divide 84 by 2, the answer is going to give us 42. We also need space to do that, so let's just create the space. The fraction that we have there is 66 divided by 42. As you can see, 2 is becoming our friend. Again, we can break down this fraction by taking the number of 2's, that by dividing the numerator by 2 and the denominator also by 2. So 2 into 6 is 3 times. 2 into 6 is 3 times. So 6 divided by 2 is going to give us 33. All that over, we have 42 divided by 2. 2 into 4 is 2 times, and 2 into itself is 1. So 42 divided by 2 is going to give us 21. Like now we have the fraction 33 divided by 21. If you look at this fraction, there is no number that can go into the numerator and the denominator without any remainder. Do we have? Of course we have. This time is number 3. So instead of 2 now, we are going to use 3. We still want to make sure that the fraction is in its simplest form. Good. So again, we are going to use 3 because 3 can go both into 33 and 21. So 3 into itself is 1, into 3 again is 1. So we are going to have 11 all over. That is to say, 33 divided by 3 is going to give us 11. Then we have 21. Well, 21 is there for us. 3 cannot go into 2, so we are going to put them together. It's going to be 21, and 3 into 21 is going to give us 7. So our fraction that we are going to have is 11 all over 7. Now let's look at the fraction again. Do we have any number that can go into 11 and 7 without any remainder? No, that does it. We are using 2, suddenly we use 3. Now there is no number that we can put into 11 and 7 without any remainder. But yet we can further simplify the fraction 11 all over 7. That is to say, 7 goes into itself as once. 7 goes into 11 is just once. Remainder what? Remainder 4 all over 7. So when we divide those fractions that we added, when we simplify it, we are going to have one whole number 4 all over 7. That is it for the triquections. We move ahead to the lesson proper. Not forgetting, the lesson is on what? On addition and subtraction of fractions with unlike denominators. So we move into the lesson proper. This is to add or subtract fractions with unlike denominators. Rewrite the fractions as equivalent fractions with a common denominator, then add or subtract the fractions, and always make sure your answer is in its lowest or simplest form. Make sure your answer is in its lowest or simplest form. As you can see, this is the exact same procedure that we are using in the previous lesson and also in the triquections. So we are going to employ this same method in order to solve what we have that is going to be under subtraction. As you can see, the first question that we have here, is 5 all over 9 minus 3 all over 8. 5 all over 9 minus 3 all over 8. Remember, the denominators are not the same. The denominators are unlike. So in order to subtract rather these two fractions, we'll have to make sure that the denominators are the same. So what we have is 5 all over 9 minus 3 all over 8. We said in making sure that their denominators are the same, what we do is we take the first fraction and multiply it by the denominator of the second fraction, and also take the second fraction and multiply it by the denominator of the first fraction. That is exactly what we are going to do. Then perform the operation, which is subtraction. So this is going to give us 5 all over 9, that is 5 will be multiplied by 8, and 9 will be multiplied by 8. That is for the first one, minus, remember the operation here is subtraction. Then we have minus 3 all over 8. Again, we are going to take the second fraction, that is 3 all over 8, and multiply the numerator and the denominator by the denominator of the first fraction, which is 9. So we're going to have 3 times 9 and also 8 times 9. Remember, the reason why we are doing this, we want to make sure the denominators are the same. All right, as you can see, we've multiplied 5 by 8. We've done the necessary multiplications that we need to make sure the denominators are the same. So 5 times 8 is going to give us 40. We are multiplying the numbers on the numerator of the first fraction. Then 9 times 8 is going to give us 72. That is it for the first fraction. Then we move to the second fraction, where we have 3 times 9, and 3 times 9 will give us 27 all over 8 times 9, that is 72. All right, we need some space to do that. So now you realize that we have simplified the fractions and the denominators are all the same. They both have a denominator of 72. So we can go ahead and perform our operation. So what we are going to have now is 40 minus 27 all over one of the denominators. This is going to give us 72. Now what we simply did here is, because the denominators are the same, so we are going to subtract the numerators and maintain a denominator. So if you subtract the numerator, that is 40 minus 27 all over 72. So 40 minus 27 will give us 13 all over 72. Now as you can see, do we have any number that can go into 13 and 72 without any remainder? Well, there is no number that can do that. So the simplest form that we can leave our answer is 13 all over 72. So we can conclude that when you subtract 5 all over 9 minus 3 all over 8, your answer is going to give you 13 all over 72. So let's move ahead to our next question. All right, here we have another beautiful question. We have 4 all over 6 minus 3 all over 7. I repeat that, 4 all over 6 minus 3 all over 7. As you can see, again, the denominators are different. The denominator of the first fraction is 6 and the denominator of the second fraction is 7. So obviously they are unlike denominators. In order to solve this problem, we'll have to make sure that the denominators are the same. In order to do that, you're going to take again the first fraction and multiply both the numerator and the denominator by the denominator of the second fraction, and we're going to take the second fraction, that is 3 all over 7, and multiply it by the denominator of the first fraction, which is 6. So we're going to do that right away. We're going to have 4, that is all over 6, multiply 4 by 7, that is the denominator of the other fraction, and 7 also by 6 by 7, that is the denominator of the first fraction by the denominator of the second fraction. Then we have minus. We have 3 all over 7. Again, we are going to do the same thing. We are going to multiply that second fraction, the numerator and the denominator of the second fraction by the denominator of the first fraction, which is 6. So we are going to have 3 times 6 all over 7 times 6. Then we do the operations. That is going to give us, if we have 4 times 7 will give us 28 all over, that is the numerator of the first one. Then 6 times 7 will give us 42. Good. That is it for the first fraction. Then we move to the second fraction. The second fraction, what we have there is 3 times 6. Well, 3 times 6 is 18. All that over 7 times 6, and 7 times 6 is 42. As you can see, we've attained our objective in making sure that the denominators are the same. As you can see, the first fraction now is 28 all over 42, and the second fraction is 18 all over 42. So what we have in this text is 28 all over 42 minus 18 all over 42. So we can now apply the rule that when you are subtracting two fractions that have the same denominator, you subtract the numerators and maintain the denominator. So we are going to have 28 minus 18 all that over 42, just one of the denominators. So this is going to give us 28 minus 18 will give us 10 all over 42. Now let's look at the fraction that we have. It seems that the fraction that we have, we can break it down further. We can write it in its simplest form by dividing the numerator and the denominator by 2. So 2 goes in the 10 is 5 times. 2 goes, that is for the numerator. Then the denominator 2 goes into 4 is 2 times. 2 goes into itself is 1. So we are going to have 5 all over 21. So looking at the fraction 5 all over 21, it is already in its simplest form. There is no number that can go into both numbers without any remainder. So the answer to the question is going to give us 5 all over 21. The other question that we have, as you can see, the topic under discussion today is addition and subtraction of fractions with unlike denominators. Now we have a question that has both addition and subtraction. So we are going to solve it using the knowledge of addition and subtraction. But first, we look at the fractions. We have 4 all over 5 minus 2 all over 3 plus 1 all over 4. So you can see all these fractions, they have different denominators. So we'll have to make sure that they have the same denominators before we perform the operations. So in making sure that they have the same denominators, just like the previous ones, you'll have to multiply the first fraction by the denominator of the second and the third fraction to create another fraction that is equivalent to this fraction, but at the end we realize that all the denominators will be the same. So in doing so, we are going to have 4 all over 5. We are going to multiply 4 by the denominator of the second and the third fraction, which is 3 and 4 respectively. So we are going to have 4 times 3 times 4, also the denominator which is 5, times 3 times 4. Then we have minus, because the operation there is subtraction. 2 all over 3. Again, 2 all over 3 is another fraction. So we are going to multiply the numerator and the denominator of that fraction by the denominator of the first fraction and the last fraction, which is 5 and 4 respectively. So we are going to have 2 times 5, 4, and also 3 times 5 times 4. So that is it for the second fraction. And finally, the third fraction, which is 1 all over 4. Now 1 over 4 is the third fraction. We are going to multiply the numerator and the denominator of that fraction by the denominator of the first and second fraction, which is 5 and 3 respectively. So we're going to have 1 times 5 times 3. Also the denominator, which is 4, we are going to multiply it by 5 and 3. You're going to have 4 times 5 times 3. Then we perform the multiplications. The first one we have is 4 times 3 times 4. 4 times 3 times 4. 4 times 3 will give us 12, and 12 times 4 will give us 48. 12 times 3 will give us 48. Okay, the fraction of the first one now has a numerator of 48. Then the second one we have 5 times 3 times 4. 5 times 3 times 4. 5 times 3 times 4 is equal to 60, because 5 times 3 is 15, and 15 times 4 will give us 60. Then we have minus. We move to the second fraction. We have 2 times 5 times 4. 2 times 5 is 10, and 10 times 4 will give us 40 all over 5 times 3 times 4 will give us 60. Then finally, to the last fraction, we have 1 times 5 times 3. 1 times 5 is 5, and 5 times 3 will give us 15, all that over 4 times 5 times 3. 4 times 5 times 3 will give us 60. Now, as you can see, if you observe, we have all the fractions having the same denominator. The first fraction has a denominator of 60, the second one has a denominator of 60, and the third one has a denominator of 60. So now we can perform what we want. When adding or subtracting fractions of the same denominator, all you have to do is add or subtract the numerators and maintain the denominator. That's exactly what we're going to do. So this is going to give us 48 minus 40 plus 15 all over 60. We added the numerator of the first denominator, subtracted from the numerator of the second denominator, fraction rather, and we add the numerator of the third fraction. So 48 minus 40 plus 15 will simply give us 48 minus 40 will give us 8, and 8 plus 5 will give us 23. All that over 60. So what we did is we subtracted 48 minus 40 plus 15, which gives us 23 all over 60. So if you look at this fraction, that is 23 all over 60, there is no number that we can get into 23 and 60 without any remainder. So the fraction is in its lowest form already. So the answer to that question is going to give us 23 all over 60. I will read the try questions. What you will do is you will try them at home. If we meet the next time, we are going to do the corrections of the try questions before we move further. So the first one we have is 7 all over 13 minus 2 all over 9. 7 all over 13 minus 2 all over 9. That is the first one. And the second one we have 2 all over 11 plus 3 all over 5 minus 1 all over 2. I repeat, 2 all over 11 plus 3 all over 5 minus 1 all over 2. So you can try this at home, and that brings us to the end of the lesson. Until we meet again, take care of yourself. Thank you.
Have your say.
Fellow Gambians, my government has approved a $500 million emergency fund, which the Ministries of Health and Finance will work on for disbursement.